Now we're going to be getting into chapter 6, and I'm going to start by showing you something that Mr. Harding came up with. It's kind of funny. So let's say you're trying to launch a water balloon at an unsuspecting friend, but just to be sneaky, we're going to launch it over a building. You need to know the solution in order to figure out where the balloon is going to land, because anything launched on Earth follows a parabolic path. So chapter 6 gives us ways to solve parabolas. Hopefully parabola is a familiar word to you by now. So here's some other things that parabolas are used for, very often used in the science and business fields. In business, you can either maximize profit or minimize cost. In science, mostly it's used to find the time a particular event will occur. So before we really get into the meat and potatoes of this lesson, we're going to just talk about this example first. So if you want to kind of think about it, where is the solution on a graph? And that's a really important thing to understand before we continue with this lesson. So to find the solution for this, for example, let's just take a look at what the graph looks like. Y equals 2x plus 4. And so hopefully you remember this. If we look at this form, this is the slope-intercept form where m is the slope and b is the y-intercept. And so I'm looking at the slope to be 2 or 2 over 1 if it helps. And the intercept, the y-intercept, is 4. So let me go ahead and graph this equation. I'm going to start with the y-intercept of 4. And then I'm going to follow the slope of 2 over 1. So I would go up 2 over 1, up 2 over 1, and so on. All you really need to graph a line is just 2 points. So I'm going to go ahead and connect this. And I'm going to throw some arrows on the end. And so this is asking where would this, excuse me, where would this cross the x-axis? As you can see, it crosses right here at -2. Excuse me. And at this particular point, if this was going to be an ordered pair, this would be -2, 0. And so it's important to realize that y equals 0 at this point. And so that's how we're sort of going to go through this. It's really important to know that at the solutions for the zeros or the roots of any equation, y equals 0. It's wherever the graph crosses the x-axis. And so know this. All 3 of these words are talking about the same exact thing: solution, 0, and root. Make sure you write that down. So taking that idea, we're going to go ahead and find the solutions for this example. And so the very first thing I'm going to do is make sure it's set equal to 0. Check, that's already done for this example. Next thing I'm going to do is factor this trinomial. At this point, everybody should have factoring down. If you do not, make sure you take out some time to come and see me and we can hammer that out. So I'm going to factor this trinomial. This is going to be x minus 7 times x plus 4. And so what I'm seeing right here is a product. I have a product of 2 binomials that's equal to 0. Well, if you think about it, the only way I can get 0 if I multiply 2 terms together is if one of those terms is 0. So that means either this one has to be 0 or this one has to be 0. So what I'm going to do is set each of them equal to 0. And you may or may not remember this called a t-bar. I think some people refer to it as that. So I'm going to solve. This is going to be 7 over here. This is going to be -4 over here. And I'm going to go ahead and put this in a solution set. Not a bad idea to double check to make sure both of these work. but that's the solution for this particular problem. Please note, a really important thing to remember is that solving is extremely different than just factoring, okay? When you're solving, you're finding the solution. You're finding what x is equal to. When you're factoring, when you're only factoring, you're not going to have this equals 0. And a lot of times people get the two confused. So I'm going to follow the procedure for this example. Very first thing I want to do is get everything set equal to 0. So I'm going to subtract 64 from both sides of the equal sign. So I'm going to have x squared minus 64 is equal to 0. And I'm going to factor this. This is the difference of two perfect squares. And then I'm going to set each factor equal to 0. And solve. So x equals negative 8 over here. X equals positive 8 over here. So those are my two solutions. Now, if you remember, this came up a little bit in the last unit. If I just left it as this, you can do that too. However, if you are the one to introduce a radical into solving an equation, you also have to introduce a plus or minus in front of the radical because you're going to get two different roots. So I don't know if you can see that, but I just added in a plus or minus in front. And so if I take the square root of 64, it's 8, but I have to make sure I have that plus or minus there, and it's really x equals positive or negative 8. I'm going to have you try example 4, even though it's not in red. Go ahead and try number 4. And then, so here's the procedure. Very first thing we want to do is set it equal to 0. Second thing you want to do is factor. And third thing you want to do is solve, and that involves setting each factor equal to 0. So go ahead and try number 5. I'm going to give you a hint for this one. This one's going to, when you're factoring this one, you're actually going to pull out a greatest common factor. Okay, so that's my little hint, hint, nudge, nudge for that one. So now we get into a different type of problem involving quadratic equations. So this wants us to write in a quadratic equation in the form of this. It should be equals 0 on the end of this for the given roots. So we're sort of going to work our way backwards. So before we do that, I just want to go back just a minute. And so now our starting point now is going to be here. Oh, that could have been a better arrow. And we're just going to backtrack and write it in this form. So take a look at what happens here. We're going to start with what x is equal to, the roots. So then we're going to set each one equal to 0, and we're going to put each one in a set of parentheses, and then we're going to multiply it out. Okay, so we're just working backwards for these examples. So really what this is telling me, if these two numbers are the roots, that's telling me that x equals 3 and x equals negative 5. The next step, if I'm going backwards, is to solve it, set each one equal to 0. So this means I would have x minus 3 equals 0. This would be x plus 5 equals 0. Then I'm going to put each one in a set of parentheses and multiply it out. So I'm going to go ahead and use double distributive. And so I'm going to get x squared plus 5x minus 3x minus 15 equals 0. And so the answer to this type of question, go ahead and combine like terms here. This is the corresponding quadratic equation given these roots. Okay, so I want you to go ahead and try number 7. You're going to follow the same exact procedure, and we will talk about this more tomorrow.